Okay, so we've seen all the different types of transformations now, and let's go ahead and let's just put together some basic rules to help us identify transformations and how they change the graphs of their base functions. So if you notice, when we shift the graph, that is when we just pick up the graph and move it either left or right or up or down, what we're doing in those cases in terms of the equation is we are adding and subtracting. Okay? So anytime you see addition or subtraction, that's usually a sign that the graph is being shifted by that value. The next thing we saw was stretching and compressing. And this was associated with either multiplying and dividing. Okay? And so whenever you saw something multiplying a variable or multiplying a complicated expression, that was a sign that you were doing a stretch or compression of some sort. And then finally, there was the reflection. And that corresponded basically by multiplying or dividing by -1. So whenever you saw an operation of the form adding or subtracting, you know it's a shift. Whenever you see multiplying or dividing by some number like 2 or a half, that corresponds to stretching or compressing. And if you notice that you're multiplying or dividing by a negative, that's a sign that you're doing some sort of reflection. All right? So those are the three main ways that operations line up with the various transformations. Now, you'll notice also that the direction of the transformation changed. So if we looked at the transformations, there were the horizontal transformations. Okay, so this is a different class of transformation. So the horizontal transformations, when did those happen? Those are operations on x before the evaluation of the function. Okay, so if you did something to the x variable before you did what the function was asking you to do, say square rooting or squaring or taking a sine function or a cubic or something of that sort, these operations affected the x variable before you did that evaluation, and that corresponds to doing something to the input, i.e. doing some sort of horizontal operation. So if you notice that, that was always going to be a shift in the horizontal direction if you were adding something to x before you were doing the major operation to it. If you were multiplying something to the x or dividing by the x, that was a stretch or a compression, that is away from the y-axis. And reflection, if you had a negative x before you evaluated the function, that reflected in a horizontal way, that is across the y-axis. Now, the other thing you should have noticed with horizontal transformations is they feel weird. They feel backwards, and that's because they kind of are. They're inverse or backwards from your naive intuition. So for example, if you added something like 10 to x, you would think, oh, I'm adding 10 to the x variable. Well, 10 to the x variable is 10 to the right, so that should be moving the graph to the right. And then if you actually did that, it actually went to the left. So your initial guess, that is positive x is to the right, is actually incorrect. You need to do the inverse operation, that is the opposite operation, which means you go in the negative direction. Likewise, if you multiply by 2, you would think that would make the variable bigger, that is, you stretch horizontally, but since it's the inverse, you need to do the inverse of multiplying by 2, which is dividing by 2, that is halving everything. So every time you see something that's a horizontal operation, it's an operation on x, and it's an inverse operation. Now, vertical operations are the operations on the output. Okay? So these are operations that you've done after you've evaluated the function. So if your function is something like squaring, then it would be something that you did after you squared whatever happened to the x. And these operations would affect the graph vertically. So if you added or subtracted vertically, that means the graph shifts up or down. If you multiply or divide, it means it stretches or it compresses. And then if you multiply or divide by -1, then it reflects vertically. So the motion is vertical, and that means that it's across the x-axis, like so. And the nice thing about vertical operations is that they are very straightforward. And what that means is that if you add 2, it does exactly what you want. You go up 2, you subtract 2, it goes exactly 2 down. And if you multiply by 5, it just stretches by 5. There's nothing complicated about it. So anytime you're doing anything with transformations, here's your general sort of categories. If you add or subtract, that's a shift. And if it's a shift, you add or subtract. If you stretch or compress, that's the same as multiplying or dividing within the function. And if you want a reflection, that's the same or equivalent to multiplying or dividing by -1. Any operation that you do to the x before you evaluate whatever your function is going to be a horizontal action, and it's going to be the inverse of what your naive intuition tells you to do. And likewise, any operation that happens on the output is a vertical operation, and that's going to be very straightforward. It's going to do exactly what you think it should do. Okay. Now that we have a just sort of general sense of how to associate various operations with our transformations, let's go ahead and apply that to a specific example here. Now, if we look at this, we have y is equal to 3 times the square root of x plus 4, close the square root, minus 2. Now, anytime we're trying to figure out what transformations we need to do, we need to at least figure out what type of function it is and find the base function. Now, if we look at this, the base function is whatever function is not basically adding, subtracting, multiplying, or dividing. So if we look at this, the only operation that's outside is the square root. So in this case, our base function is y is equal to the square root of x. Okay? Now if we were to graph this function, the domain of the square root of function is all real value, or positive real values including 0, and it includes the point 0, 0, looks something like this, 1, 1, and 4, 2. Okay? So now we need to figure out all the transformations to apply to this graph to get this graph. Now, if we look at this graph if we look at this function right here, we'll notice that we add 4, we multiply by 3, and we subtract 2. Now, the first thing we want to do is we want to identify the horizontal operations. If we look at that, those are the operations that are associated to the x before I evaluate my function, in this case, the square root. And if I look at this, I add 4. So if I look at this, if I look at y is equal to square root of x plus 4, I'm doing something to the x before I evaluate my square root of function, so that's going to be a horizontal operation. Next, it's going to be a shift because I'm adding something, so this is a horizontal shift. So that means it has to be left or right. And then finally, if I look at this plus 4, my naive intuition tells me that I go in the positive x direction, 1, 2, 3, 4. But remember, this is a horizontal operation, so it's the inverse, or it's backwards. So we need to do the inverse operation, adding 4, which is subtracting 4. So that's 1, 2, 3, 4. So we're going to shift left 4. So that's the first thing we need to do. And now we need to figure out what happens in the vertical direction, because that's the only thing that happens in the horizontal part. So if you notice, the first thing we do is we multiply by 3. So we're going to get y is equal to 3 times the square root of x plus 4. So this is the next operation that we do. And if we look at this, we're going to multiply by 3. So we're multiplying the output of the square root, so it's going to be vertical. This 3 is multiplying it, so that means it's going to be doing a stretch or compression. And in this case, we're multiplying by 3, so our naive intuition tells us that we should stretch by a factor of 3, which means makes it bigger. And if we look at that, this is a vertical operation, so it's not the inverse, it's just straightforward. So we're going to do a vertical stretch by 3. And then the last thing that we're doing is subtracting 2. Again, that's something we've done after we've evaluated the function. So that means it's gonna be a vertical operation. We also noticed that we're subtracting, so that the addition subtraction meant that we were shifting. And -2, if I look at the y-axis, that feels like I should be going down 2. And in fact, if I think about that for a second, that's exactly right, because it's a vertical operation. So I'm shifting down 2. Now, if you notice, the operation does matter. Now, all the horizontal operations and all the vertical operations, you can flip those between each other and that would be fine. But each of the vertical operations needs to be done in the order of operations. That is, you do it in the order if you were evaluating a number. So if we looked at the square root, the first thing we would do is multiply by 3, and then we would subtract 2 if we were trying to find the value of this function. So that means that the order of operations is we're going to stretch by 3 and then shift down by 2. Now, if we look at that, that tells us how to move all the points around on our graph. So let's ask what happens. What happens to the point 0, 0? Well, first thing is I shift it left by 4, so that means it goes from 0, 0 to -4, 0. I vertically stretch by a factor of 3, which means that I take the 0 coordinate, multiply by 3, that still gives me 0, and then I shift down by 2. And so that'll give me -4, -2. Next, I look at my point 1, 1. And if I shift it left 4, that's going to give me -3, 1. I vertically stretch by 3, so that's going to multiply the y coordinate by 3. That's going to give me -3, 3. And then I'm going to shift down by 2, and that's going to give me -3, 1. Last one, 4, 2. I'm going to shift left 4, so that's going to take me to the y-axis at 0, 2. I'm going to vertically stretch by 3, so that means I multiply that 2 by 3. I get 6, so now I'm at point 0, 6. And then finally I shift down by 2, so I go from 0, 6 to 0, 4. And if I look at that, that's the graph I'm looking for. Now, if you were to check each of these coordinates at these points, or coordinates according to this equation, you'll find that all three work correctly. So for example, at 0, you have 0 plus 4 is 4, square root of 4 is 2, 2 times 3 is 6, minus 2 is 4. And so this is how we actually compile all these different operations. We go ahead and we look at what they are. We associate the addition and subtraction with the shifting. We associate the multiplication by the stretch. We notice that the stuff that happens before our base function is horizontal and thus inverted from the direction we would notice. And the stuff that happens after the square root is stuff that we do in the vertical direction and is straightforward. And this is how we sort of compose various different transformations to transform a single graph according to many different transformations.